Let's take a look at some having examples. So I'm going to run these one at a time, starting from just a reminder of our basic table. You're probably getting to memorize this pretty well. Remember, order details are like line items in an order, where you have multiple, let's say, an order with multiple line items that are associated with that order. Here, we're going to review the group by, and here that groups this order by. So, and it works with this aggregate function. So you'll expect to see sums of that order. So let's say this order, and if you summed up these values, that's what you're going to see in the result set here. So the sum of all order details under this order number equals this value, and because we grouped by and worked in harmony with the aggregate function. So here, I'm going to change my business rule a little bit. I want to see order totals only that are greater than $50,000. So filtering out those order totals that are less than $50,000. And we can see we have a handful that are greater than $50,000 that we expect in the result set. Let's look at a query that won't work. So this can't work because the where clause filters raw data, shaping the data set that aggregates work on. Therefore, it can't use aggregates. Circular problem. Let's take a look. We'll run it. There's no syntax error here. It doesn't notice a syntax error. This is a syntax error. It just says error code, invalid use of a group function. So let's look at the place where it does work. That is the very similar looking, right? It's a predicate. So having is going to look very similar to where. They have ands and ors, greater than, less than, equal to. However, it doesn't work on the data that's in the same condition. The where clause filters raw data. The having clause filters aggregated data and grouped data. So here we group by order number again, and we're going to end up with a sum of each individual order. In this having clause, then we can refer to that aggregate function where the order total is greater than $50,000. You can think of this as happening later in the query, when the raw data has already been whittled down and we're ready to perform aggregate functions on it and filter on aggregate functions. So here we see the result set of this, and we see now the order totals only that are greater than $50,000. So another condition that we're going to add to our business problem. I want orders that are greater than $50,000, but that where the price of each individual component is greater than $100. So again, let's look at that. So we would only count this in the sum. So we don't want to include $55. Only prices that are greater than $100. So you can see that result set's probably going to be whittled down quite a lot when we get this to succeed. So given that business problem, I first cut it at it. Since I already have the having clause here, it seems natural that I would go ahead and use the having clause with right here, right? And price each. Again, no syntax error. There's nothing syntactically wrong with this. It's just that the having clause can't see price each because price each comes from the raw data table. It's not part of the group, and it's not an aggregate. So let's run it. And we get an error. Unknown column, price each in the having clause. Having clause doesn't see the raw table data. So this is where I need to reintroduce the where clause, since the where clause can filter on raw data table. So now we have two predicate functions, with the where clause filtering on the raw table data, and the having clause filtering on aggregated data. Let's run it. And just as predicted, the results are slimmed down quite a lot because we've thrown out individual orders where the price was less than $100. Those individual prices are no longer part of the sum because they were filtered out of the raw data that sum is then going to work on. So another example of the having clause. Since having is a predicate, it can be as elaborate as you need. So you can have multiple Boolean expressions and multiple conjunctions within it, just like in the where clause. As long as you stick to aggregate functions, you're fine. Aggregate functions and columns that are involved in the group. So we have sum, price each, quantity order greater than 1,000, and sum of the quantity ordered greater than 600. So price times quantity, so the order sum is greater than 1,000, and the quantity order is greater than 600. And you can see that here. So we'll run it again. So we only have item counts greater than 600, and we have only order totals that are greater than 1,000. Now notice in this example, I repeat this expression here, and this is standard SQL, what you need to do in standard SQL. MySQL has a nice addition to it, and that is if you use an unquoted column alias. So if you put quotes in it and you put spaces in it to look nice on the top row here, it won't work because I don't think it looks like an identifier anymore. It's a string that got attached to that column. But if you use it unquoted, it becomes an identifier, and you can use that identifier down here rather than repeating this expression. So a nicety added by MySQL is that the having clause can refer to column aliases that are not quoted. So again, warning, non-standard SQL. So that's it for having for now. We'll probably revisit it when we get into more of the select statement. Thank you.